Okay, let's go ahead and take a look at the drill activities and the summary practice tests at the end of Chapter 10, focusing specifically on simple interest. These numbers may be different because of the algorithms that are populated in your Connect activities, and also the version of the textbook may be a little bit different. But the concept is still the same. And so this very first problem, we have $7,800 as our principal, and we have an interest rate of 4 1/4% at 18 months. We want to find out what the simple interest and the maturity value are for these three problems. So we'll start with the first one. And the first one, I'm going to still use the simple interest formula. Now, we are using interest is equal to principal times the rate times the time. Okay, if I'm looking for the interest, it's principal times rate times time. If I'm looking for principal, it's interest divided by the rate times the time. Or if I'm looking for rate, it's interest divided by the principal times the time. Or if I'm looking for time, it's interest divided by principal times rate. Okay, so here is the first question. I'm just going to fill in the values of $7,800. And then the rate is 4 1/4%. That's actually 4.25. And I'll move the decimal point 2 places to the left to make it 0.0425. And then the time is 18 months. That's a year and a half. I could just put in 1.5 years. But since it's in months, I'm just going to go ahead and leave it months. So that's 18 over 12. Okay, then interest is equal to principal times the rate times the time. $7,800 times 0.0425 times 18 divided by 12. I'm going to enter that into the calculator exactly as it's stated right there. And that will give me interest of $497.25. Okay, now to get the maturity value is equal to principal plus the interest. So I'm going to add the interest to the principal, add those two together, and that's going to give me $8,927.25. Okay, let's go ahead and look at the next problem. And using the same formula, interest is equal to the principal times the rate times the time. And I have a principal of $4,500. And then the rate is 3%, or 0.03 after I move the decimal point 2 places to the left. And then the time is for 6 months. Since I'm in months, I'm going to put that over 12. Interest is equal to principal times the rate times the time. So that's 4,500 times 0.03 times 6 divided by 12. Okay, and that's going to give us interest of $67.50. And then the maturity value is your principal plus your interest of $4,500 plus the interest of $67.50. And that will give us the maturity value of $45,67.50. Okay, let's go ahead and take a look at number 3. Number 3, we have $20,000 principal. That's a given. And 6 3/4 6.75% on this particular problem. Yours may be different, as I mentioned earlier. 3 divided by 4 is 0.75, so that's 6.75, and just move that decimal point 2 places to the left, which is 0.0675. And then the time is for 9 months. Since that's a 12-month period, I'll put that over 12. And then the interest is equal to principal times the rate times the time. So it's 20,000 times 0.0675 times 9 divided by 12. That means interest is equal to $1,012.50. And maturity value is equal to principal plus your interest. So that is 20,000 plus your interest of $1,012.50, and that would give us $21,012.50. Okay, let's numbers 4, 5, 6 are the same as 7, 8, and 9. The only difference between 7, 8, and 9, it's based upon exact interest. Anytime it's based upon exact interest is the 365-day year. On the first 3 problems, numbers 4, 5, and 6, it's based on ordinary interest. And then they also include the date borrowed and the date repaid, so we're going to have to calculate that as well. So I'm going to start with the symbol. And again, interest is equal to principal times the rate times the time. And we have principal of $4,000. And the rate is 8%, or 0.08 after you move the decimal point 2 places to the left. And the date borrowed is March the 8th. And the date repaid is June the 9th. Okay. So March the 8th, there's 31 days in March, which leaves 23 days in March. Okay. April has 30 days. May has 31. And then June, the note matures on the 9th, so I'll only use the 9 days. Add that up, and that gives me 93 days. Okay, this particular problem is based upon ordinary interest, which is the same as Banker's method. So I'm going to put 93 over 360. That's the Banker's method, or ordinary interest. Okay, now whenever I calculate that, interest is equal to principal times the rate times the time. That's 4,000 times 0.08 times 93 over 360. That's going to give me interest of $20.67. Maturity value is equal to principal plus interest. So that's 4,000 plus $20.67, and that equals $4,020.67. Okay, the only problem that I have with this particular one, I actually made a mistake here. I don't know what I did wrong, but I actually used the wrong value. My principal was supposed to be $1,000. Sorry about that. Let me change that. Let me go back and change the 4,000 to 1,000 and recalculate that. That's 1,000 times 8% times 93 divided by 360, and that means it's 1,000 plus $20.67, which equals to $1,020.67. Okay, sorry for that error there. Let's go ahead and look at number 5. Number 5, of course, the algorithms populate different numbers in Connect, and also the version of the textbook may be a little bit different. But I just completely wrote down the wrong number. That's all there is to it. But in this one, number 5, the principal is $585. And the rate is 9% or 0.09 after moving the decimal point 2 places to the left. And then it's borrowed on June the 5th and repaid on December the 10th. So I'm going to calculate the number of days remaining in June. There's 30 days in June, which means there's 25 days remaining in June. And then July, there's 31. August, there's 31. September, there's 30. October, there's 31. November, there's 30. And it matures on December the 10th, so I'll only use 10 days out of December. And that gives us 193 days. And I'll put that over 360. Okay, so therefore, interest is equal to your principal times the rate times the time of 585 times 0.09 times 193 over 360. So interest is equal to $28.23. Maturity value is your principal plus your interest, 585 plus 28.23. So the maturity value is equal to $613.23. Okay, then number 6. This particular problem the principal is $1,200 and the rate is 12%, and then the date borrowed is July the 7th. Oops. Okay. Date borrowed is July the 7th, and it is repaid on January the 10th. Okay, so July 7th. There's 31 days in July, so that gives us $24 days remaining in July. And then August, there's 31 days. Then September, there are 30 days. October, there's 31. November, there's 30. December, there's 31. And in January, that's his maturity date. That goes through the 10th. So that comes up to 187 days over 360, since this is based upon banker's method or ordinary interest. So therefore the interest is equal to principal times the rate times the time. So the principal is 1,200 times rate of 0.12 times 187 over 360. So the interest is equal to $74.80. And the maturity value is principal plus the interest. The principal is $1,200 plus the interest of $74.80 equals your maturity value of $1,274.80. Okay, number 7, 8, and 9 are all the same as these particular types of problems, but instead of dividing the time by 360, you use exact interest, which is 365. Okay, so I'll go ahead and skip those three. And that brings us to the next part of this chapter. Okay, the principal is 400 and the rate is 5%. Again, your values may be different. We don't know the time, so that's what we're going to solve for. And the simple interest is $100. Okay, so time is what we're solving for here. Time is equal to the interest divided by the principal times the rate. So the interest is 100, and then the principal times the rate is 400 times 0.05. That equals 100 over, let's calculate the denominator now. 400 times 0.05 is equal to 20. Um, 180 divided by 20 is equal to Did I do that right? Ooh, never mind. I misread again. This is not 180, that's 100. 100 divided by 20 is equal to 5. So the time is equal to 5 years. Whenever you have a whole number on your calculator, then it's considered to be years, and any decimal value is considered to be number of days in a year, but you'll always have to take that times 360. So if you have 0.16667,235, take that value times, don't round it or anything like that, take that value times 360, and that will give you the number of days in a year based upon ordinary interest. Okay, let's go ahead and take a look at this next one. Number 11 is okay, 7% interest. So it's 0.07 after you move the decimal point 2 places to the left. And then it's for 1.5 years. Okay, 1.5 years could be written as 1.5 because 1 divided by 2 is 0.5, so it's 1.5 years. Or you could convert that to months, which is 18 months over 12 months. I'm going to use years, which is 1.5. And I don't know what the principal is, but I do know that the interest is $200. Okay, principal is what I'm solving for. So principal is equal to interest divided by the rate times the time. So that's interest of 200 divided by 0.07 times 1.5, and that is equal to 200 over, then I'm going to calculate what's on bottom, 0.07 times 1.5, and that equals 0.105. Okay, now that equals 200, got to clear the calculator first, divided by 0.105, and that comes up to 1904.76. So the principal that generates a $200 interest at 7% interest for 1.5 years is 1904.76. Okay, now let's do number 12. And number 12 we know it's $5,000 interest, and the rate is unknown, and the time is for 6 months and some in months. I'm going to put that over 12, and the interest is $300. Okay, so therefore I'm looking for rate. Rate is equal to interest divided by principal times the time. Okay, the interest is 300. Principal is 5,000 times 6 divided by 12, and that equals 300. And now I need to calculate this entry of 5,000 times 6 divided by 12, and that equals 2,500. Okay, now I'm ready to clear the calculator again and enter 300 divided by 2,500, and that equals 0.12, or 12% after you move the decimal point 2 places to the right. Okay, now the last problem is based upon partial payments that you make using the U.S. rule. Okay, the scenario that's set up on this one is that we have a principal, the amount that we originally borrowed, it's equal to $10,000. Okay, the rate is 8%, and the length of time is 240 days based upon ordinary interest, which is 360-day year. Okay, we're going to make a partial payment. I'll put PP for partial payment, and the first one is on the 100th day, and that amount is, a partial payment is going to be $4,000. And then another partial payment is made on the 180th day. And that partial payment is equal to $2,000. Okay, so that is what we're going to base everything upon in this particular problem. Okay, I'm going to work this to find out how much interest and what the maturity value of this problem would be if I did not make any partial payments whatsoever. So that's where I'm going to start. Okay, the principal is $10,000, and the rate is 8% or 0.08 after you move the decimal point 2 places to the left, and it's based on 240 days in a 360-day year for Banker's method. And therefore, calculating this is 10,000 times 0.08 times 240 divided by 360 equals interest of 533 33. Okay, maturity value is equal to the principal plus the interest. So that's 10,000 plus 533.33. So the maturity value is equal to $10,533.33. Okay, this is not part of the problem. I just want to show you what this looks like if you calculate this particular problem without any partial payments. We have a partial payment on the 100th day for $4,000 and one on the 180th day for $2,000. Okay, let me scroll this one over or up, and let's look at the problem from a completely different perspective. Okay, put this right up here. And we have $10,000. This is our principal, this is our rate, this is our time, and this is our interest. The rate is 8%, 0.08, and then the time, it says on the 100th day. So I'm going to do find the interest based upon 100 days over 360. And so I'm going to calculate for the interest. Okay, I'm going to kind of set this up a little bit differently. Instead of drawing a figure each time, always remember that interest is equal to principal times the rate times the time. Okay, with that in mind, it's 10,000 times 0.08 times 100 over 360. That's going to equal an interest of 222.22. Whoops. Okay, 222.22. Okay, that's the amount of interest right there. Okay. I'm going to subtract that interest of 222.22 from the amount of my partial payment of $4,000. Okay, the interest less the partial payment of $4,000 is going to give us $37.77.78. So that is the amount that we're going to credit this customer for making a partial payment. So I'm going to subtract $37.78 from the previous balance of $10,000. And that will equal $62.22.22. That's the new adjusted balance, AB. Okay, now for the second step of this, I'm going to use interest is equal to principal times the rate times the time. And so that now our new adjusted balance of $62.22.22 times the rate of 8%, or 0.08 after moving the decimal point 2 places to the left. Now our time on this one is, our first partial payment was on the 100th day. Now our second partial payment is on the 180th day, so that's 80 days later. So 80 days later at $2,000. Okay, so times the time of 80 days later divided by 360, that's going to equal interest of $110.62. Then I'm going to subtract the $110.62 from the previous balance, or excuse me, from the partial payment of $2,000. And I'm going to credit this customer's account for making that partial payment for $1889.38. Okay, to find out how much is owed, I'm going to subtract $1889.38 from the previous balance of $62.22.22. And that will give us our new adjusted balance of $43.32.84. So this is our new adjusted balance. Okay, now kind of move that up a little bit, and we have, well, let's see, before I go any farther, we have, according to the original problem, I went too far. Sorry about all the scrolling here. We made our last partial payment on the 180th day, and the difference between 180th day and the 240th day, 180 to 240, that's 60 days. So we have 60 more days without a partial payment. So I need to find out how much interest needs to be applied for that 60 days. Okay, so let's run back down here at the bottom. And we're going to take interest is equal to principal times the rate times the time. And we're going to take our previous balance of $43.32.84 times 8% or 0.08 after moving this point 2 places to the left. And then I have 60 days remaining until maturity over 360. So that means interest is going to be $57.77. Okay, the only thing here is I did not have this to apply to a partial payment, so I can't subtract it from a partial payment. Since this is interest that we owe the bank, I'm going to add this to my previous balance of $43.32.84 plus the $57.77 interest. So my balance I actually owe now is $4,390.61. So that's my adjusted balance. The balance that's due. This is what I'm looking for right here. I owe that particular amount. Okay, how much did that really affect me? Did it affect me very much? Well, first of all, I know that I had interest of $57.77. And I had interest of $110.62. And I had interest of $222.22. Add that up, and the total amount of interest paid is $390.61. That's the total interest that I paid, $390.61, as a result of making those partial payments. Look what I would have had to pay had I not made those partial payments. Instead of $390, I would have had to pay $533.33. So the difference by making these partial payments I saved myself $142.72. Okay, this concludes the drill activities at the end of the chapter. Let's go ahead and take a look at the summary practice test at the end of the chapter, chapter 10. Scroll down and get a clean slate here. Okay, we're going to start from scratch right here, and here's the summary practice test. It says Lorna Hall's real estate tax of $2010.88 was due on December 14th, 2015. Lorna lost her job and could not pay her tax bill until February 27th of 2016. The penalty for late payment is 6.5% of ordinary interest. First of all, we want to know what the penalty is. Well, that penalty is the amount of interest. So we're going to use the same formula that we were using before. Interest is equal to principal times the rate times the time. What is the total amount Lorna must pay on February 27th? Well, that is the maturity date, and so the maturity value is equal to the principal plus the interest. So to calculate this particular problem, let's give it a shot. Interest is equal to principal times the rate times the time. Okay, she has a tax bill of $2010.88 and a rate of 6.5%. That's 6.5. Then move the decimal point 2 places to the left, which is 0.065. And then the time, I don't know. I know that it was on December the 14th. That's whenever she took out the loan. And I need to find out how many days are remaining in December. Well, there's 31 days in December, so that gives us a total remaining date of 17 days remaining in December. and it matures on February 27th. So January, there's 31 days, and then February, it goes through the 27th day. So this will give us a total number of days of 75 days. So this is based upon ordinary interest, so that's going to be 75 over 360. So 2010-88 times 0.065 times 75 divided by 360 will give us interest of $27.23. That's the amount of her penalty. Okay, the amount that she has to repay on February the 27th is the maturity value, which is equal to the principal plus the interest. So add the principal to the interest. That's 2010.88 plus interest of 27.23. That will equal $2038.11. That's the amount of her repayment on February 27th. Okay, let's go ahead and look at the next question. Next question is Ann Hopkins. Remember, these values may be a little bit different based upon what's populated in the Connect activities or the end of the chapter exercises, because it's a different version. But Ann Hopkins borrowed $60,000 for her child's education. She must repay the loan at the end of 8 years in one payment with 5.5% interest. What is the maturity value Ann must repay? Okay. Interest is equal to principal times the rate times the time. I use PERT. PRT. Okay. That principal is $60,000. And the rate is 5.5%. That's 5.5. Move the decimal point 2 places left, which is 0.055. And then the time is for 8 years, so I just put that in there as a whole number. Interest is equal to principal times the rate times the time. So 60,000 times 0.055 times 8 is equal to $26,400. So we are going to add the principal plus the interest, which is going to give us the amount of repayment at the end of the 8-year period of $86,400. Wow. Interest of $26,400. That is incredible. Okay, now this next problem, number 3. On May 6th, Jim Ryan borrowed $14,000 from Lane Bank at 7.5% interest. Jim plans to repay the loan on March 11. May 6th to March 11. Okay, there's quite a few. That's almost a year. Assume the loan is on ordinary or banker's method or ordinary interest. How much will Jim repay the maturity value on March the 11th? Okay, so we have to do a little bit of calculation on that one. And let's see, we've got we borrowed $14,000 from Land Bank at 7.5% interest at 7.5. Move the decimal point 2 places left to make it 0.075. And we need to calculate the number of days from May the 6th. Well, there's 31 days in May to give us the number of days remaining in May of 25 days remaining in May. And then June, there's 30 days. In July, there's 31 days. In August, there's 31 days. In September, there's 30 days. In October, there's 31 days. November, there's 30 days. December, there's 31 days. And when does it mature? It matures on March the 11th. So January, there's 31 days. February, there's 28 days. And it matures on March the 11th. So add all that up, and that comes up to 309 days. So it's 309 over 360 since it's ordinary interest. 14,000 times 0.075 times 309 divided by 360 gives you interest of 901.25. Then all you do is add your principal plus your interest to give you your maturity value of $14,901.25. Okay, number 4. Gail Ross met Jim Ryan, which was in problem 3 at the Lane Bank. After talking with Jim, Gail decided she would like to consider the same loan using exact interest rather than ordinary interest. Can you recalculate the loan for Gail under this assumption? Absolutely. Instead of using 360 days, we're going to use 365 days. So that's 14,000 times 0.075 times 309 divided by 365. And that will equal interest of $888.90. And then add that back to the principal of 14,000. That equals the maturity value of 14,888.90. Okay, number 5. Claire Russell is buying a car. Her November monthly interest was $210 at 7.75% interest. What is Claire's principal balance to the nearest dollar at the beginning of November? Use a 360-day year, which is ordinary interest, and do not round the denominator in your calculation. So we're doing this for only 30 days is really what that question is asking. Okay, so So I don't know what my principal is. That's what I'm going to be calculating for. But I know that it's 7.75% interest, which is 7.75, and then move the decimal 2 places to the left, which makes it 0.0775. And then my time is for the month of November, which is 30 days, based on ordinary interest, which is a 360-day year. And this will generate $210 in interest. So principal is equal to interest divided by the rate times the time. Therefore, 210 divided by 0.0775 times 30 divided by 360 equals to 210. Now let's calculate the next part, which is 0.0775 times 30 divided by 360 equals not that answer. Okay, try that again. 0.0775 times 30 divided by 360 Okay, let me try a different calculator. That's not giving me the correct answer right there. What is 0.0775 times 30 divided by 360?
It's about 0.006458.
Well, that's not right. What did I do? Oh, okay, yeah, that's right. Never mind. I have lost it. It is 0.006 458. Okay, now I need to recalculate that. Okay, so now 210 divided by 0.006458 is equal to $32,517.80, and then rounding it to the nearest whole dollar, $32,516. There we go. Okay, then finally a partial payment problem on the last one. Comet Lee borrowed $16,000 on a 6% 90-day note. After 20 days, Comet paid $2,000 on the note. On day 50, 30 days later, Comet paid $4,000 on the note. What is the total interest and ending balance due by the U.S. rule using ordinary interest? Well, again, I'm going to calculate this one to find out how much interest he would pay if he did not take those partial payments. So I'm going to do that by starting off with this. Okay, $16,000 times 6% or 0.06, and so total number of days is 90 days over 360. Let me calculate that. That equals $240. $240 is the total amount of interest that will be applied to this particular problem if no partial payments were made. Okay, that means I'm going to go ahead and apply the partial payments. So remember that interest is equal to principal times the rate times the time. Okay, my principal is $16,000 times the rate of 6% or 0.06. And for my first partial payment, I did this after 20 days. So I'm going to apply this interest for 20 days over 360. And that equals $53.33. I'm going to subtract $53 and let me put this over here. I'm going to subtract that $53.33 from the first partial payment of $2,000. So I'll be able to credit their account and give them credit for $1946.67. Then I'm going to subtract $1946.67 from the beginning balance of $16,000. So my adjusted balance is $14,053.33. So that's the adjusted balance so far. Now I'm going to do this again, and I'm going to take $14,053 for the principal times 6% times 30 days later, because remember they're doing this on 20 days we applied a $2,000 partial payment, and on day 50, which is 30 days after that 20th day, we applied a $4,000 partial payment. So I'm going to use 30 days on this one. And that will equal interest of $70.27. I'm going to subtract the $70.27 from the partial payment of $4,000. And I'm going to credit this interest payment for $39.29.73. Then subtract that balance of $39.29.73 from the beginning balance of $14,053. And the adjusted balance, oops, that's got 33 cents. Sorry about that. Forgot the 33 cents on the end of that, so that's 33 cents. And the adjusted balance is $10,123.60. That's the new adjusted balance. Now we need to find out the number of days. That's through the 50th day. And there's a total of 90 days, so we have 40 more days without any type of partial payment. So we're going to take that problem again with $10,123.63. $123.60. Is that what I had? Yeah, $10,123.60 times 6% times 40 over 360 equals $67.49. Okay, now I'm going to take $67.49 and I'm going to add it to the previous balance of $10,123.60, and my now balance outstanding will be $10,191.09. That's a balance outstanding, the balance that's due. So basically, here's the amount of interest that was applied. If you add that up, that will give you a total of $191.09. Okay, if you did not take the partial payments on this particular loan, and you paid the entire amount in full at the maturity date, that would have been $240. So the difference between $240 and $191.09 is $48.91. So I actually saved $48.91 by making these partial payments. Whenever you get into mortgages, that will actually calculate into tens of thousands of dollars, so you could really save potentially a lot of money. But anytime you make partial payments to reduce the amount of interest that you owe overall can always be beneficial for you. Sometimes not a lot, but sometimes extremely significant. This concludes the drill activities and the summary practice test for Chapter 10.